So in this video, we are going to go over the 1-3 assignment, which is summarizing piecewise functions, what we covered in section 1.3. And so to start, we are going to do number 1, where we are going to graph the piecewise function f of x. And you'll notice that I have Desmos pulled up over here on the left side. And so if you need a chance to catch up, you could pause the video and just start by getting our 3 pieces graphed into Desmos. Notice I have f of x equals on each of them, and then I'm going to go over how to type in the domain restrictions. So you can see that on my graph right now I have 3 linear functions, but with a piecewise function they each are going to have a restricted domain, which is going to cause for just pieces of each graph to show up. And so we use the squiggle brackets and we type in the domain exactly as you see it, -6. If you use the less than symbol and then hit the equal sign, it changes it to a less than or equal to, or you can use the keypad down here to get those symbols. So we are going to type each domain in behind every function. And so for -2, that's defined when x is between -4 and 2. And then our last one, our domain is when x is greater than or equal to +2 and less than or equal to a +4. So now you can see that our 3 lines look a lot different. This piecewise does happen to have each piece connect to it. And so since you're getting to use technology, when you go to sketch this on your paper, it's expected that you at least have a pretty good and accurate graph, because you can grab these endpoints, -6, -4, this where they meet, -4, -2, any y-intercepts, again another point where they meet, and then like x-intercepts. Your graph should be fairly accurate. So the one thing that Desmos does not do for us is decide what needs to go on the ends of each of these pieces. And so if you don't put anything, a lot of times it's assumed it goes on forever. So we need to decide between opened and closed dots. So if you look over here, when x is -6, x did not want to be equal to -6, so we are going to put an open dot there. When x is -4, our top function wanted to equal -4, which would mean closed dot, but this middle one did not. So since they meet right there, that closed dot's going to overrule the open dot. When x is +2, this middle one did not want to equal +2, but the last one did. So same thing, that closed dot's going to overpower that open dot since they're shared right there. And then when x is a +4, x does want to equal, so another closed dot. And that's the first one. For the next one, we're given the graph and we need to come up with the piecewise function, so these missing pieces here. And so we can see that we have 2 linear functions and then we have a parabola in the middle. This first linear function is defined between -6 and -2. Notice there's an open dot at -6, which is why that's just a less than symbol, and then all the way to -2, and so there's not an open dot here, so that means we are equal to -2. The parabola, this quadratic here, is defined between -2 and +2. And our last linear function is defined between 2 and 6. Okay, so now to write our equations, we already have the x squared done. This horizontal line, the slope is 0 and the y-intercept would be 4. So that's just the equation y equals 4. And then this other one over here, we would need slope and y-intercept. And so keep in mind that these boxes are each representing 2 on my graph. So I would go up 2 over 1, up 2 over 1. And so that gives me a slope of +2. So I group that with the x. And then notice that we don't actually have a y-intercept. And so you're just going to have to imagine where it would go, or you could solve for this algebraically. But if I went up 2 over 1, up 2 over 1, that would end up being all the way up to 8. Now for the last one, I would recommend you pausing this video, trying this one on your own, and then you can check your answer at the end of the video. Same thing, we're going to graph in Desmos. I already have my domain restrictions done. So again, you type each of the pieces of the function separately with their domains behind them in those squiggly brackets. Again, keep in mind that Desmos doesn't show you open or close dots, and there is a lot of dots that you're going to have to place here since this isn't a continuous piece. So to do that, I'm going to go ahead and grab this, move it over. And so again, we're looking at those alligator symbols. At -5, it's strictly less than, so an open dot. At -2 on the red one, same thing, open dot. But at -2 on the blue one, that is a closed dot because it's or equal to. At 2 on the blue graph, open dot. Green on both ends, they are or equal to's, so closed dots there. And that is it.